Hola, Algebra students. Welcome to the explanation of the problems for the 8.4 extra practice. I really do hope that you guys try doing the problems by yourselves first before you watch the video, but I made this video in case some of you really need a lot of help or just want a little more guidance since it's been a while since we've done problems like this. Okay. The directions for this worksheet are to solve by factoring if possible. If you look at the first problem, remember that these problems always have an equal sign when you're solving. Okay, so if you look at the first problem, the equal sign separates all the terms, and on the other side it's got the 0. In an upcoming lesson, we'll have terms on both sides of the equal sign, and our job will be to move them to one side and obtain 0 on the other side. Okay, since we have a binomial, the first thing we need to check is GCF. So the GCF for 5 and 30 is 5. But these also have an x in common. So I'm going to divide it by 5x. Your GCF goes in front, and you're left with 1x minus 6 in parentheses. Since x minus 6 is not a difference of squares, then I'm done factoring. If this had been a difference of squares, meaning I could square root each piece and the variable was squared, I could keep going, but I can't. So I'm going to set each factor equal to 0. And you only set linear factors equal to 0, meaning they're only the ones that have a variable of x to the first power. Okay, this is multiplication, so I'm going to divide. And you get x equals 0 as one solution. Subtraction is canceled with addition. So you get x equals 6. Number 2 is also a binomial. Notice that the 0 is on the left side this time. That doesn't matter. 0 can be either on the left side or the right side, but before you can solve by factoring, you need to make sure there's a 0 on one side of the equal sign. Always check for GCF. The GCF of 6 and 24 is what? If you said 6, you're correct. The GCF of 6 and 24 is 6. They both don't have an x, so the GCF is only 6, not 6x. Bring down the 0, put your GCF in front, and you're left with x squared minus 4. This binomial in the parentheses is a difference of squares because I can square root x squared. It's got a difference, a minus, and I can square root 4. Do you remember how to factor a difference of squares? You square root each piece, and then you're going to have two binomials, one with a plus, one with a minus. The square root of x squared is x. The square root of 4 is 2, so you're going to have x plus 2 and x minus 2. Now remember what I said earlier. You're only going to set linear factors equal to 0. 6 does not have a variable of x to the first power. So if I set it equal to 0, that doesn't make any sense. 6 doesn't equal 0. But you can set x plus 2 equals 0, and you can set x minus 2 equal to 0, because these have operations that I can work with. Whereas 6 equals 0, there's no variable, so there's no adding, subtracting, multiplying, or dividing that I can do to solve. In these, I do have an operation to cancel. So your two solutions are -2 and 2. Okay, if you look at number 3, it is a trinomial with a leading coefficient of 1. Always check for GCF, but for the most part, if you have a leading coefficient of 1, your GCF is going to be just 1. They don't all have the same variable, but with quadratic trinomials, you're supposed to find two numbers that multiply to the outside values. Remember, there's A, B, and C. So you have to find two numbers that multiply to A times C to the outside numbers and add to the middle. So you want to make a list of all the numbers that multiply all the factors of 54. 1 and 54. Does 2 go into 54? How many times? Does 3 go into 54? How many times? Does 4 go into 54? Does 5 go into 54? Does 6 go into 54? 6 goes in 9 times. And that's it, because 7 doesn't go into 54, 8 doesn't, and 9 does. All right, which ones can make 15? Well, I could do 18 minus 3, or I could do 6 plus 9. So let's try the 3 and the 18. For the addition to come out negative 15, the 18 would have to be negative. But if I use 3 and negative 18, then the 54 doesn't work. So I can use 3 and 18 to make the addition give me negative 15, but then the multiplication would not be positive 54. It'd be negative 54. So it can't be 3 and 18. So let's try 6 and 9. If I use 6 and 9, for the addition, they'd both have to be negative. So that would work. That would give me negative 15, and negative 6 times negative 9 would give me positive 54. Now I can use a shortcut since my leading coefficient was 1. So this factors to x minus 6 and x minus 9. Those are the two numbers that we checked that equal 54 and when they're multiplied and equal negative 15 when they're added. But the directions didn't just say to factor, it said to solve. So I'm going to go ahead and set each of these equal to 0. They're both subtraction, so I'm going to cancel both of them with addition. So I'm going to have an answer of x positive 6 and positive 9. X equals 6 and x equals 9. Number 4 is also a trinomial with a leading coefficient of 1. Always check for GCF, but if you don't find one, you're ready to try to find two numbers that multiply to the outside, so multiply to negative 44, and add to 7. So if you haven't done so already, list all the factors of 44, starting with 1 and 44. Does 2 go into 44? Yep. Does 3 go into 44? What about 4? What about 5? And so on. And you keep going until you find all the ones that work. I need two numbers that either add or subtract to get 7. 11 minus 4 is 7. So 11 and negative 4. Check to make sure that the multiplication works. Does 11 times negative 4 give you negative 44? Yep. Does 11 plus negative 4 give you 7? Yes. I can use the shortcut for factoring. So it'd be x plus 11 and x minus 4. So it's a positive 11 and a negative 4 in factored form in the parentheses. But to solve, I need to take them out of the parentheses and set each binomial equal to 0. It's really important for you guys to know that the answer is not positive 11 and negative 4. Those are the answers in the binomials. The solutions come when you set those binomials equal to 0. So the correct answers are negative 11 and positive 4. Okay, luckily, number 5 and number 6 are also trinomials with a leading coefficient of 1. So for number 5, you have to find two numbers that multiply to negative 80 but add to negative 2. Multiply to negative 80 and add to negative 2. In number 6, you had to find two numbers that multiply to 56 and add to negative 15. If you didn't get a chance to do that on your own, please take a minute and do it now. Make your full list of all the factors of 80 and all the factors of 56. Pause the video now. Okay, the numbers that would work would be positive 8 and negative 10. So I'd factor it into x plus 8 and x minus 10. Set each of these equal to 0 and solve. Cancel addition with subtraction. Cancel subtraction with addition. So your two solutions are negative 8 and positive 10. Here, they both had to be negative. Negative 8 and negative 7 would make the multiplication equal 56 and the addition equal negative 15. So I'd factor this as x minus 7 and x minus 8. That's what it looks like when it's factored, but since we're solving, we would have to set each of these equal to 0. So the correct answers for the solutions are positive 7 and positive 8. Okay, for number 7, always check for GCF. 3, 1, and 4. The only number that can divide all of these, or the only number that goes into all of these, is 1. They don't all have a variable, so I can't say that they have a GCF besides just the number 1. But because it is a trinomial, I need to multiply the first and the last number. So 3 times negative 4 is negative 12. And I have to find two numbers that multiply to negative 12 but add to negative 1. Take a minute, make a list of all the numbers, all the factors of 12, and find two that will add to negative 1. Pause the video if you haven't found these yet. The numbers that would work are 3 and negative 4. Since the leading coefficient is not a 1, I need to factor this by splitting the middle term. So this negative 1 is going to be replaced with the two numbers that we found, positive 3 and negative 4. Except I'm going to put an x on them because 3x minus 4x is the same as negative 1x. So I haven't changed the value of the problem, I've just changed what it looks like. Now I'm going to find the GCF of the first two terms. The GCF of the first two terms is 3x because they both can be divided by 3 and they both have an x. Now I'm going to find the GCF of the second two terms. The GCF of the second two terms is negative 4. So my two binomials that this factors to are 3x minus 4. Those are the two GCFs. And then if I divide the remainders, 3x squared divided by 3x is 1x. 3x divided by 3x is 1. That's what goes in the second binomial. Set each one of those equal to 0. This one's easy because you just subtract the 1. The other one, you're going to have to do a little bit of work. You have to cancel addition and subtraction first, and then divide. Does 4/3 reduce? Nope. So it stays as 4/3. As I look at number 8, I see the numbers 6, 11, and 10. They're not all even, they're not all divisible by 3, so it looks like they don't have a GCF. But if you want to, you can take the smallest number, divide it by the two bigger ones, see if those reduce. If you notice 6/10 reduces, so the GCF of those is 2. 6/11 doesn't reduce, the GCF there is 1. I checked 2 first. Can I divide all these numbers by 2? Nope, I can't divide 11 by 2 evenly because it'll give me a decimal. So even though we got a GCF of 2 when we reduced 6/10, the GCF of all of them is actually 1. But I need to find two numbers that multiply to -10. And, oops, not 10, because it's 6 times -10. So I have to multiply to -60, right? 6 times -10 is -60. But they have to add to -11. So take a minute, list all the factors of 60, and find two numbers that will add or subtract to -11. Pause the video now if you haven't found them yet. The correct numbers are 4 and -15. Since the leading coefficient is not a 1, I am going to factor this by splitting the -11x into a positive 4x and a -15x. Remember, those are the numbers that came from this. Okay, I'm going to find the GCF of the first term, the GCF of the second two terms. So pause the video if you haven't done this problem yet. I want you to find the GCF of both of those. You can unpause the video when you have found them. Okay, the GCF of the first two is 2x. The GCF of the second two is -5. And as I finish factoring these, I'm going to put the 2x minus 5 and 1 binomial. And the remainder of the divisions, so 6x squared divided by 2x is 3x. 4x divided by 2x is 2. So the remainders go in the other binomial. And then I'm going to set each one equal to 0 and solve. Cancel addition and subtraction first, then divide. 5/2 does not reduce. Neither does -2/3. So your solutions are -2/3 and +5/2. Please remember to send me a message through Remind if you have any questions. See you soon.